Dear Calculus 1 students, this video is for you guys. We will be going over 10 limits, and we'll just do them with algebra, and of course, I have the file for you guys in the description. Go ahead and try the questions first before you watch this video, okay? And here we'll be going over the limits as x approaching a finite value. In the next video, we will go over the limit as x approaching infinity. So let's get started with the first one. And of course, we should always plug in this value into all the x's and see what we get. When we do that, negative 2 to the third power is negative 8. Plus 8, we get 0 on the top. And then when we put negative 2 in here, square, we get 4. And then multiply by 2 is 8. Minus 8, we also get 0 on the bottom. So that means we have to do more work. We cannot draw any conclusion yet. And the work that we can do here is that we see we have a sum of 2 cubes. So we can actually factor it. Likewise, we can also factor the bottom, but let's focus on top first. Let me remind you guys the formula. When we have a to the third power plus b to the third power, the sum of 2 cubes, this factors to be a plus b times a square minus ab plus b square. So we see that here we have x to the third power. Of course, that's x and then to the third power. For the 8, this is the same as saying 2 to the third power. So x is the a, 2 is the b. So we can factor that. And when we apply that, well, we get the limit as x approaching negative 2. We first get x plus 2. And then we are going to have a, which is the x. Well, let me actually put the x in red and the 2 in red as well, just to make it prettier. I know it's kind of not pretty anymore. Let me fix it for you guys. Okay. Parentheses x plus 2. Much better. Alright, continue. A square is going to give us x squared. So we will have the x squared here. And then minus ab, which is x times 2. And that's put it as 2x. And lastly, we add b squared, which is 2 squared. You can put it as 4, but let me write it as 2 squared for now. So that will be the factoring for that. Now for the bottom, we see that we have 2 and 8 right here, so we can factor out 2 first. So let me put it down, and then we will get x squared minus 4. This is the difference of 2 squares. So this is x squared minus 2 squares, so we can factor this, and we will get the 2 right here, and then we will just get x minus 2 times x plus 2. Okay, what do we do next? We see that we factored it, and then we can cancel this and that. So go ahead and do so. And you know, we just got rid of the 0 over 0 situation. We can plug in the negative 2 into all the x's and see what happens. Okay, so we will have parentheses negative 2 and then square minus 2 times negative 2 and then plus, this is just a 4 over 2 right here times x is negative 2 and then minus 2. So let's see what we get. This is positive 4 and then plus 4 and then plus 4. So on the top we have 12. On the bottom, this is negative 4 times that is negative 8. And then perhaps we can it's not just perhaps, we can reduce that by 4. So we get 3 over 2 negative, right? So negative 3 over 2. And that will do it. That's the first one. Now for the second one, we see that we have a square root. So maybe we should just multiply the top and bottom by its conjugate, right? No, don't do that yet. Because let's go ahead and plug in 1 to all the x's and see what happens. So if we do that, we get 1 minus 1, which is 0, of course. And then we have square root of 4 times 1, and then plus 5, and then minus 1. And check this out. On the top, we get 0. That's good. On the bottom, this is 9 in the square root, which is 3. 3 minus 1 is 2. Now, what is 0 divided by 2? 0! Yes. So in fact, this is actually the easiest one on the handout. But it can cause you trouble if you just multiply the top and bottom by its conjugate. So remember. Always plugging this number into all the x's first. If you can draw conclusion right away, if you get a nice number, then you have the nice answer already. That's it. Alright, for the third one, of course, let's go ahead and plug in 0 into all the h's. Let's see. Okay, I will just show you guys. Okay, for the third one, of course, we're plugging 0 into all the h's first. When we do that, we get negative 5 squared, which is 25, times 2 is 50, and then this is 7 times negative 5, which is 35, but negative. So we have 50 minus 35, which is 15, and then minus 15. So we do end up with 0, and on the bottom, we also have 0. So this is a 0 over 0 case. That means we have to do more work. So let's see. Here we have h minus 5 squared, so we can just multiply the out, right? Let's go ahead and do that. Here we are going to get the limit as h approaching 0. And you might notice that I purposely leave some space right here because I'm just going to write down the results on the top, and then hopefully it's enough space and then we can just work out the computation. By the way, here we have 2 times. Open this, we get h squared minus 2 times this and that, which is 10h, and then we add the 5 squared, so we get 25. So this part is this. And then, of course, for this, we can just distribute. So go ahead and draw the arrow if you like, and then we get plus 7h minus 35, and lastly, we have the minus 15, and then O divided by h. And now you see right here, we can just distribute this 2, which is 2h squared minus 10, no, minus 2 times 10, which is the 20h minus, and then plus 50. Alright, so this is what we have, and let's see if we can combine anything on the top. Okay, we can combine this and that, the h terms, and then also this is 50, negative 35, and also negative 15. So what do we get? Let's see. Here we will have the limit as h approaching 0. And just remember to write down the limit every single time, just if you want to show work legitimately. Alright, so we have 2h squared on the top. And moreover, this is negative 20h plus that, which is minus 13h. And 50 minus 35 is 15, and then minus 15 is just 0. And then O divided by h. Okay. And we see that on the top here we have this h and that h, right? So we can factor the h out. So we have 2h minus 13. And we see that this h can be cancelled out with that h. So in the end, we can just put this 0 into this h, and we can get 2 times 0 minus 13. And ladies and gentlemen, the answer is minus 13. Negative 13, yeah. Okay, for number 4, first let's plug in negative 5 into all the t's, and let me just tell you, we will end up with 0 over 0, so we have to do more work. But what do we do though? In this case, we have a complex fraction because we have 1 little fraction, 2 little fractions instead of the big fraction. So this is what we can do. This is a small denominator, likewise that. Multiply the top and bottom by this and that. So let me just go ahead and write that down. Multiply the top by 3 times t plus 2. Likewise, we do the same thing on the bottom as well. And here's the secret. The reason that we multiply this is because we want to fix the complex fraction, which is because the top right here. So just go ahead and multiply out the top, like so. And on the bottom here, just leave it for now. Wait for the good thing to happen. Okay, so here we are going to get the limit as t approaches negative 5. And when we do this times that, we will just have the 3. Okay, and then when we do this times that, the 3 cancels. So we add the t plus 5. Sorry, I said the answer already. T plus 2. Okay, and then right here, I will just put down the 3 first, and then we have the t plus 5 times t plus 2. So far, so good. Now, do not cancel the t plus 2, because the top is really what? When we combine this, we get t plus 5. So in fact, we cancel this and that, okay? On the top, we have 1. Keep that in mind. Then, we plug in negative 1 into the, we plug in negative 5 into the t here. We are going to get 1 on the top over 3 times negative 5 plus 2. Okay, this is negative 3 times that, we get negative 9. So 1 over 9. Negative, of course. That's it. Okay, number 5 is slightly different because we have our function, and that function is piecewise. And in this case, you see that we have the limit as x approaching 4. So in fact, we have to check both directions, both pieces. So here we go. First, we are going to check the limit as x approaching 4, and let's do it from the left-hand side first, for the negative direction first. And if we are talking about 4 negative, that means x is less than 4. So we are talking about this piece right here. So f of x is considered to be 3x plus 1. So to do this, go ahead and just plug in 4 in here. You don't have to worry about the 4 minus, just plug in 4 in here. Because this right here works out very nicely. You see, we get 3 times 4 plus 1, which is just equal to 13. So the left limit is 13. And then let's go ahead and work out the limit if we approach it from the positive direction or from the right direction. In that case, we take this to be our function. So we have the x to the second power minus 3. So plugging 4 into here, we get 4 squared minus 3, and guess what? This is also equal to 13. Because the left limit and also the right limits are the same, that means we can draw a conclusion that this limit is also equal to this number, which is 13. So let me write down the limit as x approaching 4 of our function. This right here is equal to 13. All right, for number 6, plugging negative 1/2 into all the x's. I will tell you, it's going to be 0 over 0. All right, so not easy one. For this one though, let me tell you, it's unfortunately not easy to factor the top because we have 4 terms. We can try to factor by grouping, but it's not that easy. And way that we can reduce this is to use polynomial long division. So let's actually just go ahead and do that. So here, let me put it on the side. Everything on the top inside here, so we have 2x to the third power minus 7x squared minus 2x plus 1. And then I will put down the 2x plus 1 on the outside here. And here we go. What times 2x will give us 2x to the third power? Well, we just need x squared, right? And I will line up here. We need x squared. Take x squared, multiply by that, we get 2x squared. Well, sorry, 2x to the third power, because x times x squared, we get x to the third power. Next, this times that is just plus x squared. And remember, when we do long division, we will have to subtract. So we subtract this and that. 2x to the third power minus 2x to the third power is 0. Next, this is negative 7 minus 1. So we have negative 8. And then this is the x squared term. And then we bring this down, so we have minus 2x. What's next? What times 2x will give us negative 8x squared, and the answer for that is negative 4x. Take this, multiply by 2x, we get negative 8x squared. And then we take negative 4x times 1 is negative 4x. And again, we subtract. This minus that is 0, and then negative 2 plus 4. So it's actually 2x. And then we bring down the plus 1. And lastly, we see this and that are the same. So that means we just need a plus 1 here. 1 times that is exactly 2x plus 1. Subtract, we get 0. So this is the polynomial long division. If you guys need some practice with this, I can link some videos down below if you like. Yeah, so go ahead and check those out. All right, so what does this mean? This means that we are going to get the limit as x approaching negative 1/2. After we divide this and that, we will get this. Then there's no remainder. So we just have to put this down right here, which is x squared minus 4x plus 1. All right, let's go ahead and plug in negative 1/2 into all this. So we're looking at negative 1/2 squared minus 4 times negative 1/2, and then plus 1. Okay, so just work this out real quick. So here we get positive 1 over 4, and then this is going to be plus 2 and then plus 1. So let's multiply this by 4 and 4 and multiply this by 4 and 4. So all in all, we see this is 8 plus 4 is 12. 12 plus 1 is 13 over 4. So that will be the answer for this one. So what should we do when we see the question like this for number 7? Yes, we are going to plug in this number into all the x's first. And again, we will get 0 over 0. Okay? So it's not going to be easy. Alright, here we have square root instead of a square root. But it's okay. Let's just use the conjugate and see what we can do with that. Alright, so first off, let's multiply the top and bottom by the conjugate of this, which is just we are going to change the sign to a plus. So we are going to have square root of 13 plus square root of x and then plus 4. And of course, we do the same thing on the bottom. So square root of 13 plus square root of x and then plus 4. So far, so good. And now let's multiply this out. Multiplying out the conjugates, it's not bad at all because we can just square the first and then minus square the second. So this is going to give us the limit as x approaching 9. When we square this, we just get 13 plus that. So we have 13 plus square root of x. And then we will have to minus the square of that. 4 squared is equal to 16. So we have 16 here. And on the bottom, we'll just leave it as how it is. So let's write it down. X minus 9 times parentheses square root of 13 plus square root of x plus 4. Okay. And now we see that this is 13 minus 16. So we can work that out, which is just going to give us square root of x minus 3. What do we do next? In fact, you can approach this 2 ways. The first way is we can multiply the conjugates one more time. Or you can actually factor this as well. In class, I show people how to multiply this by the conjugate. So perhaps, let me do that in this video and then see what you guys like, yeah? So how can we factor x squared? Sorry, how can we factor x minus 9? So let's see, x minus 9. This is actually factorable, but it's in a strange way. Check this out. This is the same as saying square root of x squared minus 9 is the same as 3 squared. Do you see it now? This right here is going to give us square root of x minus 3 times square root of x plus 3. Yeah, so that's how we can factor x minus 9. Even though there's no square, but if you can squeeze out a square, then we can factor it. So let's actually just do it here. Yeah, do it this way. So right here, I will put it as square root of x minus 3 times square root of x plus 3. And this is perfect because now you see the top and this cancel each other out. So if you do it this way, you do not have to do the conjugate again. But if you do the conjugate, it's okay. You will still be able to cancel out this right here. Alright, in the end, what do we get? Just plug in 9 and then see what happens, right? So we get 1 on the top over, we just have this factor now on the bottom, right, from here. And then let's see, we will have square root of 9 plus 3 in the first parentheses. And then for the second one, again, plugging 9 to here. So we have square root of 13 plus square root of 9 and then plus 4. Okay, let's see what we can have. 1 on the top over. This is 6. This is 3 plus 13 is 16. Square root of that is 4. So 4 plus 4 is 8. So we have 6 times 8, which is 48. And of course, that's just computation and you should be able to work that out. But the final answer is just 1 over 48. Okay, for number 8, this is very similar to number 2. You guys can see number 2 has the minus 1 here, right? But for number 8, we have the minus 3. So if you plug in 1 into all the x's, in this case, we end up with 0 over 0. So we have to do more work for this one. And because we have a square root, let's use the conjugate. Even though the square root is on the bottom, still use the conjugate. So multiply the top and bottom by the conjugate of this, which is square root of 4x plus 5. Change this to a plus, and then we have the 3. And of course, do the same thing on the top. Square root of 4x plus 5 plus 3. And then let's see. On the top is just going to be that. Because the reason that we multiply this is because we want to fix the conjugate, right? We want to fix the square root on the bottom. So we keep the top as how it is. X minus 1 times square root of 4x plus 5 and then plus 3. Over. Multiply the bottom out. To do so, we just square this, which we get 4x plus 5. And then we minus the square of that, which is 3 squares just equal to 9. Alright, have a look. 5 minus 9 is minus 4. So on the bottom, we get 4x minus 4. And guess what? We can factor out 4. And guess what? Here we have x minus 1. Here we also have x minus 1. So they cancel each other out. And guess what? We can just put a 1 into this x and then compute it. So we are going to get square root of 4 times 1 plus 5 and then plus 3 on the top over just a 4 on the bottom. And let's see what we get. This is 9 in the square root, which is 3. 3 plus 3 is 6, and over 4, so this is 6 over 4. Of course, reduce that, we get 3 over 2. Alright, this is number 9, and you guessed it, if we plug in 0 into all the h's, we get 0 over 0. But be sure you really just check it before you do anything. Alright, so here we see that we have h plus 2 to the third power. So it would be a good idea to just multiply it out. And for this right here, if you know the formula, of course you can use it. But I would like to just show you guys the multiplication for that. So let me write this down 3 times on the side. We are talking about h plus 2 times h plus 2 times h plus 2. And then let's multiply out this and that first. I will put this down in blue. Okay. So when we do that, we get h squared, and this times this is 2h, and then we have another 2h. Combine them, we get plus 4h. And then lastly, we have the plus 4. I just multiply that out. And then we multiply this with h plus 2. Okay, and then we take this and distribute it, so just kind of keep track, this times this. We get h to the third power, and then this times that, which is plus 2h squared. I'm not going to draw the arrow because it's going to be too messy. So this times this times that. Then we take 4h times that, which is plus 4h squared, and this times that is plus 8h. Lastly, 4h. So let me just put it up, plus 4h, and then plus 8. Okay, and we can combine this and that together, and then this and this together. So I'm going to put down the result back there, and we are going to have the limit as h approaching 0. This is going to be h to the third power, and then this and that is 6h squared, so we add 6h squared, and then this and that is 12h and plus 8. Cool. Then we take the negative 5 and distribute it inside. We get negative 5h and then minus 10. And lastly, don't forget we still have that plus 2. And all this divided by h. So far, so good. And now what do we do next? First off, we see that 8 minus 10 is negative 2, and then plus 2 is 0. So they actually all cancel out. That's pretty nice. And we can combine this and that. This is the 12h, and then this is the minus 5h. That's about all. So in fact, I'm just going to show you guys that we can cancel this and that all together. This and that together is plus 7h. Okay? Well, we have h to the third power plus 6h squared plus 7h, all divided by h. We can factor out an h on the top. So this is the limit as h approaching 0. factoring out the h, and then we get this is h to the second power, and then we will have plus 6h, and then plus 7, all divided by this h. And yes, we can cancel out this h and that h very nicely, and in the end, we can just put a 0 into this and that. So we are going to get, I'll show you guys all the work. 0 squared plus 6 times 0, and then plus 7. The answer is just equal to 7. Alright, for number 10, we have another piecewise function. So let's go ahead and check both directions. Okay, so for number 10, we have another piecewise function. So that means we have to check both directions. And let's go ahead and just check the limit as x approaching 0 minus first. And in this case, this means x is less than 0, so we take 1 over x to be f of x. Alright, how do we figure this out though? If you put 0 in here, we get 1 over 0, but you will just have to expect that that will give us a vertical asymptote. So I will just give you guys a graph and then we'll see where the graph goes, right? Okay, 1 over x, I'll put it down right here. We have a vertical asymptote when x is equal to 0. And then we also have a horizontal asymptote when y is equal to 0 right here. And the first piece goes like this. And the second piece goes like that. Right? That's the graph for 1 over x. Okay, as x is approaching 0 from the negative direction, we are looking at this piece. And we see that the function is going straight down. That means this limit is equal to negative infinity. Alright, we will take cosine x to be the other piece, right? And that's when we have the limit as x approaching 0 plus. That's cosine x. And for this right here, we just put 0 into cosine. So we have cosine of 0, and you have to note your trig values. Cosine 0 is equal to 1. And as we can see, these two, they are not the same, right? They are not equal. So what does that mean? That means this limit doesn't exist. So I'll just write this down right here for you guys. The limit as x approaching 0 of our piecewise function here, I'm not going to write down equals doesn't exist. That doesn't make that much sense. So I'll just put down DNE, which stands for doesn't exist, right? Does not exist. Alright, so that's it for this worksheet. Hopefully this right here helps, and especially if you're starting with Calc 1, then this is one of the first things that you will have to know. And let me know how your class is going, and let me know what other materials that you guys will need. And good luck in your calculus class. I will see you guys in the next video, because in the next video, I'm going to show you guys how to do the limit when x is approaching infinity. Right? So go ahead and check that out.